Now, just in case, suppose because the AUI can be remoted, because the AUI, the Advanced User Interface, is a web server, and you can see it's a super remote control because you can see and do anything that you can do from the front of the transmitter.
That's right.
Because of that, the functionality here in this card is almost redundant in a sense.
It is.
And as a result, it's almost possible to use those in a different way. You could program these potentially and have them monitor the status of your generator, monitor the or turn on and off the generator potentially.
That's right. That's right.
So that's a very and you would then control that through the AUI.
Correct.
SNMT is also a feature of the NV series. Some of the automation control systems, industrial control systems, talk via SNMP, and that's built in here.
Yes, it is.
Via TCP/IP.
Correct.
Okay. All right, let's talk about this new exciter. I got to say, this isn't the most beautiful exciter I've ever seen.
No, but we tried to put emphasis somewhere else, which was on the AUI. We felt that users want a single point of contact where they can configure their transmitter. We coined the phrase audio in, RF out. The exciter is an integral part of the transmitter, and it has very special functions that are quite specific to the transmitter.
You make a good point. I mean, you've got this wonderful 17-inch color display, and if you can control the exciter through that single display, why have an expensive display on the front of the exciter?
Quite frankly, we're going to close the door once the transmitter is operating, so there's no need to have something behind it.
So tell me what makes the exciter special.
Well, of course, it's a very simple design. It is an integrated design. The AUI provides complete control. There are no pots or tuning elements that are required. Again, everything is advanced user interface controlled. It's probably the best sounding box that we have, for sure.
When I look at this exciter, it looks very basic, very simple, and we've discussed the reason why, because the control is on the AUI. But what is it giving up? I mean, what features doesn't it have that the M50, for instance, the top-of-the-line exciter, has?
There are absolutely no features that it gives up. If anything, it has more features. We've given up the front panel in order to get that much more where it counts.
And it has adaptive pre-correction built into it.
It does. It has adaptive
So in
pre-correction.
essence, that exciter is not just an exciter, it's also a receiver that's listening to the output of the transmitter and comparing the signal at the output of the transmitter with the ideal signal, the perfect signal, and then supplying a correction signal to make it right.
Yeah? That's right.
That's amazing. All right. This is the AUI. We've been talking about it. This is what the screen looks like when you walk up to it. But this is static. I'd rather go live. So I'm going to try to switch this thing around and take a look at the transmitter that's on the air down in our lab. And hopefully this is all going to work. My darn, there we go. So now we're looking at the AUI in the lab, and we have an NV40 that's operating at 32 kilowatts in HD mode.
That's right. This system has been running in our engineering lab for a while, and we're conducting tests and experiments and trying to get the features of the AUI that much better and load in various other lovely features. When you first turn the transmitter on, this is the screen you're going to see. As you can see, there's a very intense level of instrumentation that's been provided. We have metering in case of troubleshooting. We have the exciter status. It tells you which exciter is active. The modulation meter is a very important function. Date and time, and of course, the biggest thing you're concerned with is how much power am I actually putting on the air.
Mm-hmm. Okay, can you walk me through the screen? Tell me what I'm looking at here.
Yes, so right here we'll see this little section is basically what we call the task area. So in this example, we see an audio spectrum analyzer. Yes, that is an audio spectrum analyzer. This is all built into the transmitter.
What's it looking at, Scott?
This right now is actually looking at the composite baseband. And you can see the left plus right and the pilot and the suppressed 38 with the left plus right in the stereo.
Double sideband suppressed stereo.
And you actually see an SCA carrier.
Let's see. Now I noticed this thing has a marker on it that I can use, so I'm going to take and move that marker across and see what my levels are. It's just like an instrumentation spectrum analyzer. So there's my 19 kilohertz pilot.
Yeah. And
I'll come around here, and I want to take a look at something, because something doesn't look right about this thing. Look around here and see. Now, who in the lab thinks that an SCA runs at 87 kilohertz?
Well, some guys with a sick sense of humor, Chuck.
Okay, can we fix that?
Of course we can.
All right.
So in this case, when you want to change your SCA setting, we'll actually go into the preset that is active.
Mm-hmm.
In this case, this is the preset number 2.
Okay.
So as you can see, there's various parameters that can be adjusted.
Yep.
Output power, the frequency, the mode, injection level.
Well, I'm curious. Go back up for a second. Does this iDock injection level mean that I can adjust that at some point in time?
At some point in time, you will be able to adjust it in 1 dB increments all the way to -10.
That's wonderful. Okay.
So if we scroll down, we'll see various other parameters, and we'll get to the SCA function.
Oh, there it is.
The SCA1 was enabled at 87 kilohertz.
Okay.
So Chuck, what do you feel comfortable with?
Well, 67 kilohertz is more or less the standard for most stations, so let's do that.
All right, and now we'll activate.
All right.
And if
Done.
we close our preset screen,
Hey, look, it moved.
we'll see that our marker at 87.
So I'm going to come over here now. And there it is. Now let me show one thing I know how to do, and that is to hit this gear here. In fact, I'm going to expand this screen and make it go to full screen.
That's right.
There's our spectrum analyzer in a large screen. Now I'm going to come over here to this gear. So I don't want to look at an audio analyzer anymore. I want to look at the RF at the output of the transmitter. And so I hit done. That's going to take a second and normalize
It has
its
to
values.
refresh and normalize, so.
Should take just a second, I hope. And looks like something started happening. While that's happening, can you explain the meters over here again?
Check your span. I bet you're
Oh, okay, yeah.
So in this case, the span was adjusted for the audio spectrum analyzer.
Okay,
So we'll set it up for a 1 meg span.
okay. Oh, yeah, look at that.
There you go.
All right. Very good. So we're meeting the math.
A passing spectrum, what I like to see.
Good. All right. Explain the meters on the right-hand side.
Well, the meters are broken down into the device type. So in this case, you can see exciter A, forward power. In this case, we have 9 watts. The reflective power is 0.1 watts, but again, for exciter A. We have module 1, various meters within that module. We may have a few others here that have been selected. No, but I'll show you where those meters are grabbed from.
So in other words, you get to define what things are showing up on that screen.
Correct. Those meters are strictly there as a troubleshooting aid.
Okay.
You can look at specific meters or a various amount of meters in the way I'm going to show you right now. So if you want to look at all the modules and their parameters, go into the system review page and actually open up a screen that gives you a summary so you can compare how one module might be doing compared to another module.
I'll look at the amount of information that is available there. And the red marks means that it's updating?
It's just updated that value.
And I can see this from wherever I am.
This is all remote.
Even on my BlackBerry or iPhone.
That's right.
Wow.
So if we close that, we'll see various other. We can go into the controller. And every meter you see in this list is available as an item that can be pulled up in that right-hand bar.
Okay.
Okay, so you can see various values are changing.
Sure. I can see the RPM of every fan.
Yeah, we monitor every fan.
Mm-hmm. So there's a tachometer in every one.
It is a tachometer reading.
Yes.
So in order to pull up a specific meter, you'll see before we didn't have controller 5 volts, but if I load it, you can probably see that scroll bar change. If I scroll down, I'll see the controller 5 volt.
There it is.
If I choose to remove it, I close it.
There it goes. Okay. Now let's go close this part. Show me what these other meters on the work area here are for.
Well, being that this system is a FM plus HD enabled system, obviously we have the transmitter spectrum being shown.
Mm-hmm.
We have what we call the LUT height, which is the amplitude correction, and we have the phase correction. And we also have a lithogist pattern, which is just showing modulation.
All right, very good.
Detail.
Now, if I wanted to close one of these, it would allow me to open up
A
tools.
plethora of other tools.
Yep.
So in this case, you could open up an EQ impulse response. So if you had to have a tilt filter enabled, you'd see a variation in your EQ response. You can close this one and open up the signal constellation.
You don't have that connected at the moment.
Unfortunately, at this point, it is not connected, but that is available.
Okay. All right.